Welcome to Eganeet students. In today's lecture, let me be dealing with exercise 8.1, chapter 8 of class 9 and question number 2. So what is the question? Let us see. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So we are given a parallelogram and we have been given one more condition that the diagonals of this particular parallelogram are equal, and now we are to prove that this parallelogram is nothing but a rectangle. Why? Because to prove any parallelogram a rectangle, what is the condition needed? Can you guess? Right. We know that for any parallelogram to be a rectangle, you need to have at least one interior angle as 90 degrees. Clear? So let us see. So first, let us take this parallelogram ABCD. Now, we join these diagonals AC and DB, and now we know that they are AC equal to DB because this is a given condition here. It has been given. So let us see how we can tackle it. Now, do you recollect any ways by which we can say that an angle can be 90? We know one property that if we have set of parallel lines and a transversal, and if we add up these two angles, which are the interior angles, C and angle B, and if these two lines are parallel and if this is the transversal, then we know that summation of these two angles will always be 180 degrees. So this property we know. Now how can we arrive at 90 degrees? We can arrive at 90 degrees by using, let us say if we have this angle B equal to angle C, what will happen? Angle B plus angle C is equal to 180, and in other words, angle B plus angle B is equal to 180, or 2 into angle B is equal to 180, and further it will lead to a very interesting result. Angle B is equal to 90, and once we have a parallelogram with one interior angle as 90 degrees, we will achieve the wanted result, that angle B has to be equal to 90, or any single interior angle of a parallelogram should be 90. Then we can prove this as a rectangle. So therefore, we can have a broad outline of how we are going to attack this problem, right? So let us see further. Where AC is equal to BD, this is given to prove ABCD is a rectangle. Rectangle is a parallelogram with one angle 90 degrees. This is something we have just now discussed. We prove that in triangle ABC and triangle DCB in this case AB is equal to DC. Now we are taking two triangles. We are trying to prove the congruency of these two triangles. And why are we interested in proving the congruency of these two triangles is that we are interested in somehow proving that angle B is equal to angle C, for the reason which we have discussed just a few minutes back. So let us see. AB is equal to DC. How are you going to achieve this? Let us see. BC is equal to AB is equal to DC. This is set of two parallel opposite sides of a parallelogram. So naturally they will be equal. So AB is equal to DC, BC is equal to BC, this being the common side between the two triangles highlighted. Clear? Now AC is equal to DB. Just see, AC is equal to DB. Why? Because it has been given in the problem itself. Therefore, in triangle ABC and triangle DCB, these two triangles will be congruent. Why? Because all the three sides are equal. So therefore, you have used the SSS congruence rule, right? So ABC triangle is congruent with triangle DCB. This leads us to an important finding in this, in the sense that angle ABC is equal to angle DCB, and that is nothing but because of the corresponding part of congruent triangle. Now AB parallel to DC. Now once again come back to this, AB and DC, these two are opposite pair of the parallelogram sides, naturally they are parallel, and angle B plus angle C will be equal to 180 degrees. So therefore angle B plus angle C के जगह पे we can write angle B once again, because B and C is same. Therefore B and C being same, therefore we can write angle B plus angle B is equal to 180 or 2 into angle B is equal to 180 or angle B is equal to 90 degrees. So we have proved what we set out to prove. Therefore we can say that this particular parallelogram ABCD is nothing but a rectangle. Thank you guys. Keep watching the channel for more such videos.